The pulse rates of 164 randomly selected adult males vary from a low of 40 beats per minute to a high of 116 beats per minute. Find the minimum sample size required to estimate the mean pulse rate of adult males. Assume that we want a 95% confidence that the sample mean is within 3 beats per minute of the population mean, and then completes part A through C below. So when we want to be able to find the sample size, we're going to use the following formula. N is equal to the critical Z value times the population standard deviation divided by the margin of error squared. Okay, so the first thing we need to do for part A is to find the critical value or the critical Z value. So we know that alpha is going to be 1 minus the confidence level. The confidence level is 95%. So as a decimal, it's 0.95, which gives us 0.05. And then we're going to take alpha and then divide it by 2. So 0.05 divided by 2. And 0.05 divided by 2 is 0.025. Okay, so what we want to do is in the standard normal distribution, we want to be able to find that critical Z value. That has an area to the right to be 0.025. So what we're looking for is the probability of Z being greater than or equal to what value that's going to give us the area of 0.025. So again, this area is what's being shaded here to the right. So let's go ahead and then use StatCrunch to determine that critical Z value. We're going to go to Stat Calculators and then scroll down to Normal. We want to make sure that we have the greater than or equal to because it's in the right tail. And we're looking for the Z-score here, so we're going to put in the area of 0.025, and we get rounded to 2 decimal places, 1.96. So therefore, that's what that equals, 1.96. So the critical Z value is equal to 1.96. Okay, so let's go ahead and write that here. Okay, now the next thing that we want to do is we want to be able to find the population standard deviation. But in this particular part, to use the range rule of thumb to estimate the population standard deviation, we have to use the formula where we have the population standard deviation is equal to the range divided by 4. So let's go ahead and do that. So we want the population standard deviation. Well, you see here in the very beginning of the first sentence, it tells us that it varies from a low of 40 beats per minute to 116 beats per minute. So the range is going to be the larger value, which is 116, minus the lower value of 40, and then we're going to divide that by 4. So let's go ahead and do that. So we have 116 minus 40, and then we're going to divide that by 4, and that gives us 19. So now we know that the population standard deviation is 19. Now the last thing that we need to now find is the margin of error. So if we look up here, it's saying that the sample mean is within 3 beats per minute of the population mean. So therefore, that's going to represent the margin of error. And now we can plug it in to find our sample size. So the formula is taking the critical Z value, multiplying it by the standard deviation, dividing it by the margin of error, and then squaring that result. So we're going to take 1.96 times 19, divide that by 3, and then we're going to square that result. So we end up getting 154.090844. Okay, and so then it needs to be rounded up to the nearest whole number as needed. So we're going to round this up to 155. So let's go ahead and put our answer in here. And there's our result. Okay, now in part B, it says, now assume that we are given that the population standard deviation is 11.2 beats per minute based on the value that the sample standard deviation is 11.2 beats per minute from the sample of 164 male pulse rates. So for part B, we're going to still use the same formula. We're going to still use the same critical Z value, which is 1.96. We know that the margin of error is still 3, but now in part B it's saying that we want to assume that the population standard deviation is 11.2. So now we're going to plug that into our formula to find the sample size. So we know the critical Z value is 1.96, multiply it by the standard deviation of 11.2, and divide it by the margin of error of 3, and then we're going to square that result. So we're going to take 1.96 times 11.2, and then divide that by 3, and then we're going to square that result. So therefore, we get the following number, which is 53.54336711. And again, we need to round up to the nearest integer, which gives us 54. So let's go ahead and put our result in here, and we get 54. Now the question says, compare the results from parts A and B, and which result is likely to be better? Well, we would say that the result from part A, 155, is larger than the result from part B. And so the result from part B is likely to be better, and that's because it uses a better estimate of the population standard deviation.